Yeah. So what we get is that this gk of omega is equal to qk of omega convolved by summation k is lambda k by 4 eta times e to the power of j omega nt. So basically I just wrote this above, and instead of just writing it above, I just convolution with a summation of k. You sort of get the same, if you sort of do the math, it's the same as this, by the way. Over here you see that qk of omega, you could write it as gt of omega times h of omega convolved by this summation. And what we have is this is a matched filter, and then this lambda k. By the way, we're supposed to find these coefficients. So that's all. I mean, that's the main thing about solving this Lagrangian multiplier. So always solving for this lambda. Over here, it's the filter taps. Then this e to the power of j omega kt is like basically a delay line in the time domain. So you have a match filter followed by a tap delay line, which is really interesting that this is what's being implemented currently, and it's all by solving this optimization problem, calculation of variation, and having as an assumption for the worst case. And what they sort of did is they extrapolated it to also solve for the average probability of error instead of finding the probability of error for the worst case. And they sort of drew inspiration from this worst case probability to get this patch filter plus tap delay line, and it works really well. So I hope that you found this video to be interesting and sort of found this to be fun. Thank you.
Subscribe.